This one has some graphs, couple graphs, g and h, and then it's got a function f, which is g over h, and it asks us for f prime of 1. It's kind of interesting, strange question. How do we do that? Well, um, so you might think that you just got to take the derivative, right? So just do the derivative of the top and do the derivative of the bottom. That's wrong. So I hope you know that when two functions are divided, you can't just do their derivatives separately. That works for added subtracted functions, but not for multiplied or divided functions. You have to do the special rules where they take turns. So in reality, it's the first one, you do his derivative first, times the second one just sits there, minus, so it's plus for the product for when they're multiplied, it's minus when they're divided. And then the first one just sits there, and it's the second one's turn. And then you've got to divide that by the denominator squared. And we're not done yet. But is that making sense? Do you remember that? That's the special rule called the quotient rule. We have the product rule and the quotient rule. The quotient means dividing. This is the dividing rule. And you can't just do them separate, just g prime, h prime. No, no, no. That works for added, subtracted functions, not for multiplied or divided. What do you got to do? You got to take turns. The first one goes first, and the second one just sits there. The derivative of the first one, second one sits there minus, and the first one just sits there, and the second one's turn over the denominator squared. Okay, so there's the correct thing. Now we want f prime of 1, right? So what's f prime of 1 going to be? Well, we're going to plug a 1 into this thing. So we're going to get, let's see, g prime of 1. Well, here, let's do this. Let me just, I know you're just writing this out and wasting everybody's time. Your time, my time. Let's just stick ones in everywhere. There's a 1. So for f prime of 1, put in a 1 everywhere. Boom, boom, boom. All right, so what is g prime of 1? Oh, good question. What in the world is g prime of 1? Well, here's the g graph, right? So what's g prime of 1? G prime of 1. G prime of 1 equals the slope at x equals 1. So right here, right there, the slope, the steepness. Remember, primes are slopes. The derivatives, they're slopes. So what's the slope right there? Well, uh, look, I'm just going to do rise over run. So I'm going to go to that point. Why don't I don't want to go to that one because that one's not right on a clear edge point. It's not right on a clear crosshairs. So I'm going to go there and there. What's that? Down 2 over 1. Slope, oh, that back. Slope equals rise over run. So that's down 2 over 1. So the slope is -2, right? The slope from here to here is down 2 over 1, rise over run. So that's g prime of 1. So g prime of 1 must equal -2. So this is -2. It's the slope at 1. What comes next? H of 1. Now that's not h prime. We'll get to h prime in a minute. That's just h of 1. I go to the h function now. I go to 1 and I go up and say, how high up is that? That looks like it's at 3.5, 3.5, right? H of 1, that means the height of the H graph at 1 minus. Okay, now G of 1. So go over to the G graph. And now we're going to go G of 1. That's 7. So that's not G prime. That's just G. That this is a 1 right here that I plugged in. That's not a prime. This is a prime. This is just g of 1. This is the height of the g function at over 1. It is 7. That's different than the g prime, which was the slope. Let me write that there for clarity. Whereas this one is height, right? height again. Now, finally right here, h prime of 1, that, like, that means slope at x equals 1, right? So prime, h prime of 1. So I'm going to go to the h function right here at 1. So this dot right here. I want to know the slope right there. That's a bit tricky. What's the slope right there? Well, you can go wherever you want, wherever looks easy to you. I'm just gonna go right there, I think. Middle to middle. I'm gonna do rise first. So rise and run. Looks like it goes up 1, right? Because it goes from 3.5 to 4.5. And it also goes over 1. So the slope right there, which is rise over run, is 1 over 1. And so it's just 1. So that means G, no, this is the H graph, huh? H prime of 1 equals 1. Now you might have one where they're over here. What would the slope be if you're somewhere past 2.5, somewhere in the second section? Well, this looks like it would be, I don't know. Hard for me to tell. Mm, Down 1. It'd be -1. Slope would be -1 if you're over there. Down 1 over 1. Because it's down and over. So down 1 over 1. Just -1. That'd be the rise over the run. If you were on this leg of the journey. You just got to pick two. All I'm doing is I'm picking 2 points. You can pick any 2 points on that piece that you want. Do whatever looks easiest to you. It's going to be the same slope between any 2 points on that piece. You think what we really, if you went all the way here to here, yep, it'd be down 1, 2, and 2.5 over 1, 2.5. See, 2.5 over 2.5 is 1. It's down 2.5 over 2. It's still going to come out -1. So it doesn't matter. Just pick any 2 points on the piece and do rise and run between those 2 points, and you'll get the slope. Remember, down is negative, right? Up is positive. So anyway, long story short, let me actually get rid of that piece because that was not our piece. It's just in case you needed that piece for your problem. Our piece was over here, and the slope h prime of 1 was 1. Over, now what goes on bottom? H of 1 squared. Well, h of 1, right here, 3.5 squared. Again, that's the height of the h function at 1 is 3.5. H of 1 squared. So there we go. So maybe I'll do one step of simplification here. Um, what's this going to be? This looks like, to me, 2 times 3.5 is 7. It's negative. So -7 minus 7 over 3.5 squared. That's -14 over 3.5 squared. Let's go to Desmos. -14 over 3.5 squared. -14 over 3.5 squared. So -14 divided by 3.5 squared. -1.1428. -1, 1.1428. Hey, we got it. Look at that. It's beautiful. I love it when it works. -1.1428, blah, 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 blah. So there we go. All right. So the trick on this one, then we had to do the quotient rule because these are divided. Quotient means divided. The divided rule, which means you can't just do the top and do the bottom. They take turns. So the top goes first, the derivative, yeah, and the h just sits there minus. Then the top just sits there and it's the second one's turn. H prime over the denominator squared, not the derivative, just the denominator squared. And then we had to plug in 1, 1, 1, 1 everywhere because it was f prime of 1. Then we had to think, what is g prime of 1? Means the slope. Prime means slope. If you have a g prime or an h prime, that's the slope of the graph at that point. If you have just regular h or regular g, that's just the height of the graph, right? You seeing what I'm saying? This is slope. This is slope because those are primes. The other two are just heights. Height and height because they're not primes. You just go to the graph, calculate the slope, or find the height. And how do you calculate the slope of a piece, this piece or that piece? You just pick any 2 points on the line, doesn't matter which 2 points, and calculate rise over run. Remember, down is negative, up is positive. And so plug it all in, and there we go.